Good afternoon, everybody. Today we're going to talk about the last problem of 2022 IOI, which is island. The problem is like this. So you have an island, which has, you have an island, and between each island, there's a path. You can go from U to V, and there's a canoes. Canoes can go from UI to VI. Basically, when you go to VI, it can come back. However, the canoe need to be maintained. So when you sail from UI to VI, you cannot immediately sail back from VI back to UI. You cannot use that canoe immediately. So the question is, if I start the journey from the first island and need to visit at least one other island, then after the journey ends, all the canoes need to be docked at the original island. So ask you to print out, basically to ask you to print out the path you're going to take. And if there's no such path, then say basically no such path. So then, so here you give you some example, right? So you can go from here to here, here to here, here to here, here to here, here, and backwards. So look at a couple of constraints. The first constraint is two islands. Second is less than 400. Then for each distinct island, there's a bunch of exactly two canoes. So then the second one is less than 1,000. Then the last one is no constraint. Okay. So then let's see, how do we do something like this? Okay, so first thing we know is if you go from if you have an island that has nothing, that doesn't go out, okay? If you have an island that doesn't go out, has no boat to go out, then this island is useless, right? Because you don't want to go there because then you're stuck. Okay, so let's first remove all the island that does not have a path, a boat to go out. Okay, you may want to do that as iterative, right? So make sure you don't have any of those anymore. Once you get that, if you look at your island 0, okay, if you look at the island 0, it must have a bunch of other islands that can get there, right? So it may be, something for each island that can get there, you just pick one of those paths. You may have multiple, right? So eventually you will get something like a tree, for example, like this, like a tree. Okay, but let's ignore the path that from island 0 to go out. Then you may have other islands that are separated. So for example, this one can go here, this one can go here, this one can go here, for example. But remember, we already removed all the island, right? Removed all the island that has nothing go out. So it cannot end there. It has to be end at somewhere in there, right? So let's say you end here. Okay, so you may have a bunch of things. So this is what? This is your strongly connected components. So then our island basically become something like this. One is island 0 is a root of a tree, and then you have a bunch of islands that goes to there. Then you have a bunch of separate components, right? You may have one or multiple components. They are strongly connected components with a bunch of, let's say, I call it tails that go into this strongly connected components. You may have multiple of this, right? For example, you could have another one, that goes like this. I mean, you could have multiple strongly connected components like connect together. So it's going to be something like this. Then what do we do? So first, let's think about let's talk about island 0. Island 0 could have, it has to have at least one way to go out, right? If it doesn't have one way to go out, then of course, then the answer is you can't make it. So island 0, let's say at least have 2 or more, more than 2 that boat to go out. Okay. So then there's multiple cases. Those two, let's see, those two go where? Let's first assume they all go back into this tree. Okay. So this is my island 0. So let's say I have 2 paths. They all go back to my tree. Okay. So it goes here, for example, go here, go here, go here. Okay. So let's say this is my X and this is my Y. Okay. There are 2 possibilities. One is the LCA of X and Y eventually go back to here. The other case was for example, X is the LCA of Y, or Y is LCA of X. Okay, so let's first consider case 1 is LCA of X and Y eventually go to island 0. Okay, so in this case, you can build something like this. Okay, so from island 0, you first go here, right? Then you go here. Then this boat, right, reach here. Then you take the boat here, reach here. You take the boat here, go there. Then you take the boat. This boat goes there. This boat goes there. This boat goes there. Okay. Now you can take the reverse path. Let's do this color. Sorry. Let's do this color. Okay. So you take the reverse path, right? This you cannot take this boat back, right? So you take, but this boat has been rested. So you take this boat, return back, this boat, return back, this boat, return back, return back, return back, return back, right? So everything went back to the original situation, and now, and you're at island 0. You basically did, a double 8, right? So that's the first case. Then could be my second case is my LCA of X and Y could be X or Y. Let's just assume it's X. Okay. So now basically we have a case like this. This is my island 0, and I have a thing to go to X. And here has a bunch of passes, but eventually, there's a Y. And I go to Y. Remember, this is a tree, right? And eventually it's go back to here. Okay, so let's do something similar like what I had before. Let's see, how do we do this? let's say I take this path here, then I take this path back, then I take this here, then I take here, and then I take, then I have this one, right? This one, okay, this boat, remember this boat? Like I took from here to here. And what I'm going to do is I'm going to take this boat and return it back, right? So then I take this boat, right? That boat, and then return it back. Take this, return it back. Take this, return it back. Okay, so now I'm good, right? So, okay, so now obviously now I solved that issue. So for island, if I sorry, this is the case that both X and Y goes back to the tree. Okay, so now let's look at a different case. Let's say case number 3. Okay, case number 3 is again I still have still talking about I have two. So case number 3 is, let's say, one goes inside the tree, the other is goes outside of the tree. Right? Remember, outside of the tree, eventually you will end at a strongly connected component. So you will have something like this. Island 0, let's say X, and X eventually will come back to island 0, right? And then you have this one goes to island Y, and it goes to a bunch of places, but eventually it goes to a strongly connected component. If you look at this case, it's essentially the same as this case, right? Because for this case, you basically can go around this and come back, right? All you want is you basically have a way to go there and come back and go there and come back, and then you iterate. So this is just a different way of doing this, 8, right? Double 8, okay? So then the fourth way is both X and Y, they don't go back to the tree. They both go to this strongly connected component. It's the same thing. So you basically have 0, you go to X, for example, go into a strongly connected components. Then you go to Y, which you go to another, eventually go to another strongly connected components. So it's the same thing, right? You do like this. You go this, you go this, you go this, you go this. Then you take this, right? You take this one, you go back here, then you go this, 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 and go back here. Okay. Now you can take this and return it back, right? So you take back, 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 back. And you take this boat and take it back, right? So this all set to original, right? So you do the same, back, 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 back. Okay, so everything returns back. Okay, so if you have, that means if you have 2, at least from island 0, if you have 2 or more boats to go out, then those are the 4 conditions, 4 possibilities, then you know how to do it. Then the other possibility is for island 0, there's only 1 boat to go out. Okay, so if it's only 1 boat to go out, again, there's 2 ways, right? One is to go back to something like this, okay? The other way is it's go back to the tree, right? One way to go back to the tree. The other way is go outside of the tree. Okay. When you go outside of the tree, remember we go to some kind of strongly connected components, right? So if you go to strongly connected components, it's the same way. You go down there, you go there, you go there, you go there. Then, of course, along the way, if you have any of those places, any of those places, you have two branches. Okay, so maybe a better way to draw it like this. So you go out to a place, to another island, right? Let's say X1. If X1 has, at least two paths, okay, which we, based on previous way, we know you can go there and return here. Then you take this boat, then go back, right? So you're set. Okay. If this one only have one thing, then you keep on only have one boat, then you go to the next one. If the next one has two, then you're done, right? If you keep doing this, anytime if you find a node that has two ways to go out, then you can solve it. The worst case is you keep on going, there's only one way. Okay. Remember, we said we already removed all the islands which only have no way out, right? So this eventually has to land back to some island that is going like this, right? So then you do then what you do is you do this. You take this, let's simplify it just like this. You take this, just different color. You take this, you go down to this one, when you reach a strongly connected component. When you reach a strongly connected component, then what you do is you do this, this, this. So you basically moved from this one, you move this one. Let's make a stop. You move this one to here now, right? Everything shifted one way. Okay. Then you take this boat, then you keep moving it. Okay. So then you move this one down here, and this one down here, and this one down. So this start come to here. Okay. Then you take this boat, then you move it one more time. Then this one goes back. Right. So you keep rotating it until you go back there. Okay. So then eventually you are able to get yourself, I think you're able to get yourself back there. So that's the way to get basically you rotate it, and that's how you can get yourself back to the condition, right? The other way to do it is you can move the other way, right? So once you go this way enough, then you can go backwards. I think that's another way to do it. You're basically just rotating enough. You shift enough of them until they will come back to the original condition. Okay, so that's the way to solve this problem. So then, of course, anytime when you get to the point that there's no solution, you can only land at the um, island with no way out. Then you say, "Oh, I'm no way of doing this." Right. So that's um, the solution for this problem. Then we're done with 2022, all those 6 problems. And what to do next is for the next couple week or two, we may want to do something fun. Then after that, it's everybody have a good summer and continue doing learning things from the USACO guide, right? So for example, the thing we just talked about, strongly connected components, they are, I believe they are in the Latin level, if I'm not mistaken, and LCAs, or maybe the advanced level. So LCAs, I think, is probably the gold level, right? Strongly connect component is advanced level. Okay, but LCA is a basic thing, right? So we do binary lift, right, for LCAs. Okay, so yeah, if you can remember what strongly connected component, go back and look at it. Okay, so good luck, and then we will see you next week for 1 or 2 more sessions for this season.